Hello guys, my name is Parth and I'm a medical student. Today we're gonna see what does that plus or minus you have before your spec number mean. What does it mean? Let's find out in today's episode.
So guys, in order to understand what the plus minus sign means, we need to understand the lenses and the problems in our eyes, right? It's a very simple thing. You know there are two types of lens. It's a convex and a concave lens. What does convex lens mean? The lens which converges the rays of light, right? So whenever light falls on the convex lens, it tends to converge it. And similarly, the concave lens has the property of diverging lens, opposite to that of the convex lens. Whenever rays of light fall on the concave lens, they divert it, right? They divert it. So, and this is the basic that we are looking at the power of convergence, right? We're looking at the power of convergence. Now, what happens in a normal eye? It's that when parallel rays of light from a faraway object fall on your lens, fall on your eye, they get focused onto your retina. This is for your simple understanding. Actually, the image formed is inverted because it gets inverted at the nodal point. That's not an issue, but for the sake of simplicity, I'm showing it like this, right? So in a normal eye, which has ability to converge those rays of light properly, rays from very long distance, let's say they are parallel to each other, they are converged at your retina appropriately, right? Image is formed at your retina. Whereas if light from an object which is close to an eye, close to your eye, falls on your eye, it is also accommodated properly onto your retina, right? It's accommodated by your eye and the image is formed at your retina. So this is what happens in normal eye, right? So it has ability to converge lens from far away. It has ability to converge the rays from a nearby object. By the way, in order to converge rays from a nearby object, you need a lot of power in order to converge those rays, because they are moving away from each other. As you can see, they are moving away from each other, and you have to focus them and at the retina, right? And so there's a thing called myopia, right? Myopia, which is very common in youngsters nowadays. Where I will make a separate episode. It deserves a separate episode, right? So this is the most common thing which most of the youngsters have. It's myopia. What does it mean? That your ability to converge is more power to converge. So more power means, right, it's good, right? You want more power. No, not really. In life, you need balance. And when things are out of balance, there's a disease, right? We know it. Now, what happens in a myopic eye, which is commonly found in the youngsters nowadays? It's simply that the rays of light are converged more, and the image is formed before the retina, right? Before the retina. Let me explain to you. When rays of light comes from a faraway object, they get converged, and the image is formed before the retina. Unlike in normal eye, where the image is formed on the retina, in this case, the image is formed before the retina. This is the retina, and the image is formed over here. And in the other case, when light comes from a nearby object, it is also formed before the retina, right? Before the retina, since the power of convergence is more, right? Now you have to decrease this convergence. You have to make the rays go away from each other. So a solution is very simple. You have to bend the rays of light away from each other. And how are you going to do that? It's very simple. You are just going to use a concave lens. Now what it's going to do is that it's going to diverge those rays a bit, and now the image is going to be formed on the retina. Now in this case, in both the cases, right? In both the cases. Now, since you are decreasing the power of convergence, this lens is said to have negative power. You are decreasing the power of convergence. Decreasing power of convergence. That's why we are saying it minus. The power is negative power. Clear? And what do we mean by plus? It's the same. In this case of hypermetropia, which itself deserves another video, what happens is that whenever rays of light fall on the eye, the ability to converge is less. The eye is not able to converge the rays of light on the retina, as the power is less. So the rays are converged behind the retina. They have traveled behind the retina. The image is found behind the retina. It's not actually possible, but if you virtually extend those rays, then the image must be formed behind the retina, right? Now here you need to help the eye to focus, to converge those rays of light on the retina. You need to aid it. You need to add a power, right? You need to add a power. So what lens is going to add the power? What lens is going to add the power? You're right. It's a convex lens. Convex lens is going to add the power. The same is going to happen with the when the object is near it. The same thing is going to happen when the object is near it. It's just simply not going to, the eye is not going to be able to focus the rays of light on the retina, and you have to simply help it by putting out a convex lens, which is going to help it to converge, which is going to give it power, which is going to add some power. It's that simple. Isn't it amazing? So here's a trick for you to not get lost. A simple way to remember is that the M in the myopia, simply you can find it out here in the more. Myopia means more power. Myopia means more power of your eye to converge the light rays. It's simple. It's so simple. And that's it. That's it from my side on this episode. See you in the next one.